All right, this last problem, it asks us to use the determinant of the coefficient matrix to determine whether the system of linear equations has a unique solution. So let's do 32 and 34. So I'm going to use Octave to do 32. On 32, I'm going to put in my matrix. C equals, the coefficient matrix is 3, -4, 2, and then 2/3, 8/9. So it gives me this. Now let's take the determinant of that. Okay, it gives me the determinant is 5.33 or 5 1/3. So for this one, the determinant of the coefficient matrix, I'll just call it C, is 5 1/3. So that's 3 times 5 is 15. That's 16/3. Therefore, it has a unique solution. All right, let's also do 34. Actually, yeah, let's do 34. So on 34, the coefficient matrix, I want to do this one by hand. I want to do it by hand, and then we'll do it on Octave. It's important for us to look at both of those on this one. So I'm going to copy that over. I'm going to put 1, 2, 3, negative, then 1, -1, 2. And now let's do some multiplying. So for those, I'm going to get -2. Then I get +3. Then -4. And then for my reverse ones, let's make them green this time. For my reverses, I get -3 +2, then -4. So you put all that together, you get 0. So the determinant of this coefficient matrix is 0. So that means it has no unique solution. Now what does that mean? It means, if I put that, well, it means that a few things. Let's put that matrix in. I'm actually going to put it in with the augmented part in as well. So I get that, and then 3 minus 2, 2, 0. So if I reduce this thing, notice it gives me that line with 0, 0, 0, 1. So it doesn't have a solution. And what the thing above told us was it doesn't have a unique solution. So I'm going to come back and I want to take the determinant of this because something interesting is going to happen. There is our identity or not our identity, our coefficient matrix. And we've already seen the determinant of this thing is 0. But let's get Octave to compute it for us. When Octave computes the determinant, it gives us this answer. Instead of just saying 0, it says 8.3267 times 10 to the -17th. Now, if you think about what that is times 10 to the -17th, you've got 837, and then you're moving the decimal way over here. So you got 17 or 16 zeros in front of it. So why is the computer telling us that instead of just telling us 0? Well, it's because computers, they don't really operate using all the real numbers. They deal with round-off error. And some round-off error is happening here, and that's what's making it give us this answer instead of 0. So if I try to take the inverse of this thing, we already know that the actual matrix doesn't have an inverse. If we try to get Octave to compute the inverse, it gives us a warning saying matrix singular to machine precision, meaning that this is a warning from Octave saying that it realizes that the matrix here is actually singular and that the values it's giving for the
for the inverse are not accurate.